My name is Judy Thompson, and I'm going to be your first presenter in this session on tracking and reducing winery water usage. I understand that this is the first presentation, or one of the first presentations of the symposium, so if you wouldn't mind, just a reminder, please mute your phones, your iPads, your iPods, your clucking chickens, and your barking dogs. Please keep them all quiet during the presentation. We'll be talking for about an hour, and then after that, we're going to open up the sessions for questions and answers. So if you would please hold your questions until the end of the sessions, that would really help with time management. My name is Judy Thompson, and I'm with Winery Wise, which is the Washington Sustainability Guide for wineries. I'm going to be talking about the overall program that you can put in place to reduce your winery water usage. Stuart Childs is then going to give you examples of wineries that he's worked with and has had a lot of success in reducing their water as well as their wastewater usage. And Ken's going to talk about the equipment that you're going to need in order to collect your data on your incoming water and also your outgoing or processed water. We're going to use a couple of terms that I want to go over with first. Incoming clean water is going to be referred to as your source water. Your outgoing water, which may or may not need some cleaning, is going to be your processed water or your wastewater. So you may hear both of those terms. We'll use the terms sustainability and reducing interchangeably. Typically, when you apply sustainability practices, you do reduce your inputs. So we'll use those two terms at the same time. SOP, Standard Operating Procedure, and that does refer to a written procedure that, of course, all of you have in your wineries to describe all of your processes, right? You all have written procedures. The measurement that we will be using today to describe your water coming in or the savings you'll have is gallons of source water per gallons of finished wine. And by finished wine, we mean in the bottle. So this is an interesting presentation to give, considering that we've had an awful lot of rain this year. So should you here in Oregon be concerned about water availability? Most of my winery work was in central and eastern Washington, and if you haven't been over there, that is a true desert area. We get 6 inches of precipitation a year. We have a problem with groundwater availability. And also, Washington State really limits the new agricultural permits for water or even to take water out of the Columbia River. It's very restricted, very hard to get new water sources. So for us, it was never a question of whether or not we wanted to reduce our winery water usage. We had to. But then here we are in the Willamette Valley. You're full of rivers, lakes. You're full of water this year. Last I looked, you had 15 inches above normal for the year. You typically have over 40 inches in most of your locations for your annual precipitation. And even in southern Oregon, most locations receive over 18 inches of water per year. So should you be concerned about water availability? I talked to a number of water managers, water resource managers in the state in preparation for this presentation so that I would understand the water situation in Oregon. And there is or has been a concern that the type of drought that has hit California in the past 5 years, that same drought could happen in Oregon. You also currently do have seasonal droughts. I talked to a number of wineries here, and quite a few of them feel their wells being depleted towards the end of summer, the beginning of fall. There's also a global warming effect. Will that come to Oregon? How quickly will it come here? But let's talk about water depletion currently in the state of Oregon. You have a lot of expected growth that's going to happen here in terms of both population and also increased agricultural land. However, most of your current water sources are already fully allocated by the state. You also have what's called groundwater restricted areas. And I don't know if any of you have heard of these, but if you'll look up where the Willamette Valley is, you'll see that a lot of these brown areas, the groundwater restricted areas, are in some of your prime vineyard and winery areas. What this means is that the groundwater is already being depleted there. It also means that the state can impose restrictions on giving new water rights and even on existing water rights. There's also been no new catchment systems that have been built in Oregon in many, many decades. And when anyone suggests that there should be a new one, such as Drift Creek, apparently there's quite an uproar. There's also this thing called exempt wells. And one of my water resource managers that I talked to said that there is unbridled installation of exempt wills, particularly in the Willamette Valley, close to a lot of vineyards and wineries. An exempt well means that you do not have to apply for a water rights permit to extract the water. For a single industrial use, you can take 2 million gallons of water per year. For a domestic use, meaning a household, maybe a small pasture that you want to irrigate, you can take 5 million gallons of water per year. That's a lot of water. Another reason for looking at reducing your winery water usage is your consumers here in Oregon love it if you apply sustainability practices. They like knowing that they're purchasing from producers who are applying sustainability practices. And a lot of your sustainability certifying agencies actually require you to reduce your inputs. Proactive is always better than being reactive. When you're proactive, you typically have a lot of choices and a lot more time. But if you're reactive, say something is legislated upon you, you typically don't have as many choices and you may not have much time. Also, if you use less water, you will use less electricity. And that's something that Stuart's going to talk about in his presentation. So how do you begin? The first thing you really need to do is to get commitment. From the top to the bottom, everybody has to have commitment that you're going to reduce water usage in your winery. In fact, something that we found in the studies that we did in Washington is that if people are simply aware of the fact that you want to reduce water, sometimes your water consumption will be reduced up to 20%. But get commitment from everyone. Because really, it's not going to make sense if one of your cellar employees is sweeping the crush pad and somebody else walks by a leaky faucet and doesn't bother to report it. You're going to have to collect data. If you don't already know how much source water or processed water you're using, you are going to need to collect that data, and it's best collected over a period of a year. Be consistent with your water measurements. Whether you use gallons of water per gallon of finished wine or gallons of water per ton crushed, it doesn't matter, but do be consistent from year to year with the factor that you're using. Review your data after you've collected it, and then brainstorm your reduction options, always keeping in mind how much it's going to cost, as well as how it will affect the quality of your wine. Develop and implement your action plan, and that does include your written SOPs. And where this really comes in handy, having your written SOPs, is especially during crush, because I know a lot of you will have volunteer or maybe temporary workers. So if you want to be consistent in what you're doing, you really do need those written SOPs. Review your results, always celebrate your results with all of your staff, and then you need to either adjust your plans to go forward and decide what you're going to do next. There are a lot of free sources of information out there to help you get started on your water reduction program. And one of the best ones for smaller wineries is the Sustainable Water Management Handbook for Small Wineries. And you can go right to this website, download it. It's about a 31-page booklet. It has forms that you can customize for your winery. It gives you all the equations that you're going to need to calculate your actual water usage and your water output. If you want to advance, then I would say go to the Wine Institute website and download their booklet. But their booklet's not a book, it's more like a Bible. It's 365 pages, I believe, but it has a lot of in-depth information on what you can do at your winery to reduce your water usage. Now, if you want to use an online site for reducing water for information, go to Winery Wise. I'm going to talk about Winery Wise for a little bit, and that's Washington's web-based winery sustainability guide. We started to put this guide together in 2007, and it was meant to be a companion guide to Winery Wise, which is also online, which is the vineyard water sustainability guide. Our efforts were led by Joy Anderson, and she's one of the directors of winemaking at the St. Michel Group. Winery Wise was dedicated to educating Washington winemakers on sustainability practices, and it was always intended to be a free guide. The thing that's interesting about it is that it was written by winemakers for winemakers. So it was written by people who have an intimate knowledge of what happens at a winery, the good, the bad, and the ugly. We were able to get a grant through the Washington Wine Industry Foundation for $128,000. It was a USDA Specialty Crop Block Grant. With that money, we were able to hire experts who reviewed our Winery Wise information. We were also able to develop this website that I'll take you to in a while. And we were also able to get technical assistance for our WIPs, our Wineries in Practice. One of the conditions of our grant is that we had to show verifiable efficiencies for what we were proposing to do in Winery Wise. In other words, someone had to take the practices that we were writing about and put them to work in their wineries. That's what the WIPs did. We had 10 WIPs, and each of them could select what they wanted to work on. But some of the things they wanted to work on were fairly technical, and so our grant also allowed us to provide them with technical assistance. Now, interestingly enough, 7 of our 10 WIPs chose to work on reducing their winery water usage. And I'm going to go to the website right now for Winery Wise. And this is what the website for Winery Wise looks like. And I want to let you know that this website has a huge amount of information, and it can seem a little bit overwhelming. But if you'll scroll down here on the left, you'll see that we have 2 how-to videos. And just for your own time management in using this website, I would really suggest that you start with these videos so that you know how to use the website and you don't waste a lot of time on it. So do start with these videos. So what we asked our WIPs to do, the ones who were using their water management for their practice, is we would have them go to the water management section of the website. And here's a general explanation of the water management section. Then if you'll scroll down, we're going to go look at 2 links here. And we're not going to go to them yet, but I just want to explain. One of them is go to the checklist, and the other is go to self-assessment. What the checklist is intended to do is it's going to get you thinking about what you're currently doing in your winery and what you might want to change to improve your water usage. Then after you start to get your ideas together, you can go to a self-assessment. The self-assessment is a quantifiable series of questions that's going to allow you to gauge where your water practices at your winery are compared to an industry standard. So what we're going to do right now is just like pretend you're one of the WIPs, you want to reduce your water usage at your winery, we're going to go to the checklist. So what you'll see here as we slowly scroll down is that the checklist is a series of questions that it's going to ask you just to get you started thinking about your water reduction strategies. And as we continue to scroll down, we may come across some technical terms. And we didn't want you to have to stop and look them up. So instead what we did is we have these pop-up balloons. And if you simply click on the pop-up balloon, an explanation of the term we used or something is right there. If you continue to scroll down the checklist all the way to the end, you'll come to a series of resources. So after you've gone through the checklist, if you still have some questions, if you want to go a little bit deeper into information on reducing water usage, then you would go to these links. So now what we're going to do is go back, close that out, and go back to and down to the self-assessment. So what our whips would do is, after they did the self-assessment, then they would, after they did the checklist, they would go to the self-assessment. They would take the self-assessment and it would generate a percentage for them. So let's say, for example, one of our whips had 65%, but the winery standard right now is 89%. So that tells you that you have some improvement. So let's say the whips have done this. The next thing they have to do is their data collection. And for that, I'm going to go back to my presentation. And by the way, this next sheet that I'm going to show you, you are not expected to read it. This is the actual data from one of our WIP wineries on collecting water information. So over on the left-hand column, what they did is they listed out every single operation in their winery that either used source water or produced processed water. And then throughout the year, they kept track of how much water every single one of these processes used, and finally generated a percentage. What percent of their water was being used by what process. So these were the 3 processes that they came up with that consistently used the most amount of water: tank cleaning, barrel cleaning, and pushing wine or line sanitation. And then these are just a number of things that they tried to do to reduce their water usage in each of these categories. So tank cleaning, one of the things they just started to do is they started to use less water per cleaning in addition to recycling them. Barrel cleaning, a number of them went to steam cleaning, and actually I know that a number of wineries here already use steam cleaning, which is fabulous. Now, and something that I do want to talk about, which is at the bottom, which is introducing barrel alternatives. And to that I always say, we are in the 21st century. There are some great alternatives to barrels, and just if you haven't tried them in your own winery, you might want to experiment with them. Pushing wine, line sanitation, that was another big water guzzler. If by any chance you're applying these practices, you're changing what you're doing, but your water meter is still spinning, you may have an underground leak. And so if you see that you're applying some practices to reduce your winery water usage, but your water meter is still seems really high, take a look deeper. This actually happened to one of our WIP wineries. And water, when it's under pressure, is really abrasive. So it can turn a small hole into a big leak in a short period of time. Realistic goals. The Wine Institute says 2.9 gallons of water per gallon of finished wine is a realistic goal for most wineries. However, what we found at the smaller wineries is that you are going to have higher numbers, and it's just because you don't have the efficiencies of largeness that the big wineries have. 4 of our WIP wineries achieved under 2.9 gallons per gallon of wine, and 1 WIP winery actually got below 2 gallons of water per gallon of wine. So they had some real good reduction. So in summary, your water supply here, maybe not this year, but in most years in Oregon is finite, and it's a good idea to try to reduce your winery water usage. Gather your ideas, get commitment from everyone, measure, plan, and then implement. Keep it simple, silly. Always at the beginning, keep it very simple. Go for those big water guzzlers, and always celebrate your successes. I just wanted to thank a number of people that spent time with me so that I could prepare for this presentation. They were really generous with their time. So now I'm going to move on to Stuart, and he's going to give you some real winery examples.
Ah, that's me. That's good. So here's my presentation on winery water conservation. Judy told you about the wineries in practice, all the winemakers that we worked with. I was part of that in Central Washington. I learned as much from them as they learned from me. Here's a picture of a few things we're going to discuss today. You can see well, you should be able to identify all of those things. Tanks for cleaning solutions, water that's running down the drain maybe shouldn't, solids that escaped into your lagoon, you know, and how you might clean that up. Am I pressing these? There we go. So I just have this slide to remind me in case Judy missed anything. I will show you the common water conservation methods. Water and energy are completely tied together. Actually, I'll probably tell you about the few times when it isn't, just because they're sort of interest to me. When you're dealing with water conservation, you get ahead by conserving water, you get ahead by conserving energy, and you get ahead by having less winery wastewater. It's a straightforward thing. I just wanted to make sure you heard that from here. This is my illegible slide. A winery does a whole lot of things. There's no such thing as a typical winery. And when we looked at this is where we started on things, but here's what we learned when we went through doing water balances in functioning wineries. You can see 3 columns here, HC, GR, and PR for the wineries, and then you can see the categories. Press sanitation, not so much water, you can see 2 to 8%. Pushing and sanitizing the pushing lines, that went from 2% to 28%. Probably when you see 28% for pushing, you're talking about a winery that has expanded and expanded and expanded. It's not like a gravity flow winery where the water's all running downhill and the lines between different winery practices are close together. The 28% you see there is probably a lot of expansion in the winery. The 2% is a well-designed winery. Tank sanitation, 3 to 15%. Barrel cleaning is another high one. You know what kind of wine PR makes, right? With 0 barrel cleaning? I'm just checking. Okay. And you can see the rest of these. The interesting thing I want to point out here is there's 20 things that a winery is doing, but generally you get, do I have 8 here? There's 8 there, and that's 90% of the water. So take heart. You attack these things one at a time. You're well served to pick the big water users first. You can also see here on the subject of a typical winery, look at electrodialysis, cold stabilization, replacement kind of thing. There's 40% water in that winery PR on the side there. Vacuum pumps is especially exasperated because it's like kind of old-fashioned thinking that made you use 18 or 9% of the water there. I'll show you that when we get down to it here. Measure your water use, need to do that. When we started working with the WIPs and they hadn't measured their water, then we helped them with estimating procedures. I'll show you a couple of them in a second here. You're probably tired of hearing about standard operating procedures, but it is remarkable that as soon as you write one of those things, you get a decrease in water consumption. It's just like an education thing. Okay, here are the processes I want to go through here and conservation options. As you read through those, you'll probably understand those things. I'll just tick through them here with examples from wineries. Starting with moving either must or wine. And if you look on the left side of this, we're pushing must with water. And if you do that, the example here, 2 numbers you have to know: how big your line is and how far your press is from the fermenters. And you can see those numbers here. I highlighted the 73.5 gallons of water for 1 push, 50 feet. In a 6-inch line. Same thing for pushing wine. Those are the smaller lines you can see, and the same thing is there too. If you have a 2-inch line, 50 feet from the tank, that's 8 gallons per 50 feet, quite a bit more efficient. The must thing is a bigger number because it's a bigger pipe. Here is a real Judy, I want to say that's actually common now, that you're pushing wine with gases. You can see a pig is a pipeline inspection gadget. It's just a little ball, seals inside the line. You can see my little cartoon at the bottom. The way this works is you have wine in your line. You put in one of those balls. It's getting inserted over on the left side of the screen there. There's a little bit of water there to protect the wine from anything else that's in this pipeline. Another alternative is you can use gases. I wrote air, probably not used so much anymore unless cost is a huge issue for you. Nitrogen or argon, no oxygen is the point of this. So here's how you would push with a pig in your lines. Judy looked at that slide and said, well, Stuart, here's a really important thing. You have to control your hose runs. And she said, look at all of these lines that have to get cleaned if you're doing all your wine movements with them. Judy, I look at that and that looks good to me. I think you're being too hard on somebody who will remain nameless, right? Okay. Let's go on to tank and barrel cleaning. I wanted to go back and, oh no, we don't need that. This is 3 to 15% of water use, tank and barrel cleaning. You can see this is it's a barrel on a rack with the bung down, and there comes the first flush out of the barrel. Often we would say, you might want to have a smaller first flush out of the barrel to get as many of the solids as you can, and then progressively a second rinse would get more. Then you got to figure you're going to either use a caustic and neutralizing in tanks, especially different for barrels. And when you do that, you put those cleaning solutions into the tank, say, well, you're not going to use up all the cleaning capacity, so you are well served to catch that water and recycle it for cleaning. Here's this might be a little abstract, but you can see on the left there's a tank, and this is actually metering out the cleaning solution going into a tank. A more homegrown one by one of the most efficient water users in Washington is they just cut that barrel in half, and they have the feed line to the pump that comes out of that barrel, that half of a barrel. When the water's gone, that's your signal to stop. Water reduction. Now, it could be that you might need a second rinse in there, but by measuring how much water goes in and paying attention to these details, you can achieve really dramatic. Basically, you get set up doing one of these things, and the people who are in the winery are solving the problems. Because they're right there, they know how to do it. As soon as they know that everyone in the company's on board with that, they're more than willing to brainstorm. And you can see somebody sawed a barrel in half. That's pretty smart if you ask me. A little wagon, that's a common solution as well. Barrel cleaning, the biggest thing you can do on barrel cleaning, of course, is be careful to get the solids first. Cleaning is always this way. Remove the solids first. And then you might need one rinse in there, but then steam, as Judy mentioned, it is a really common thing. Actually, when people get a steam rig, they'll certainly do their barrels because it'll take in the vicinity of 10% of the amount that you would use in hot water, say, and then they'll use it for all kinds of other processes in the winery. That's a little note to myself on the bottom, managing the hot water in your facility. There's plenty of wineries, this is an energy thing, right, that have a continuous loop of hot water that's going around the winery so that you can have instant hot water. Well, it's not clear that you always need that, and certainly the steam rig didn't need that necessarily, and all kinds of pressure washers don't need that. They can do the heating themselves. So you should consider whether or not you need to have instant hot water in your winery. It'll be looping around, but it's costing you energy. By the way, I'd be really interested in having anyone in the room comment during questioning on all of these things, because I'm sure you have individual experiences that are important. Here's filtration, cross-flow, 3 to 16% water use. The guy using electrodialysis, it's all in there in that 40%. It's important to note, though, that if he's replacing cold stabilization, he's saving a ton of energy. Even with filtration and cleaning, it's the same thing. Collect the solids, recycle your chemicals if you can, and some of your rinses are going to be really clean. They can go again, too. Okay, general winery sanitation. You probably see these in your wineries all the time. Brooms, squeegees, pans to collect the solids. Or the second picture from the right, some enterprising guy decided he was getting too many solids down the grate, so he went to Home Depot, he told me that, and put a screen on top of it. That means you got to run over that with the squeegee now and then, but the way you handle solids is by scooping them up and moving them away, not squirting them anywhere. This woman, we call her the berry chaser because that's what she's doing, right? This little table shows you effects of diameter of hoses and whether you have a nozzle or not on the hose. I don't see 2-inch lines running in a winery very much anymore. I think that's about done. Squeegee doesn't take any water, you can see. Winery sanitation isn't a lot different from microbreweries. I was just in a microbrewery yesterday, actually, for President's Day. And you can see the same things here. On the right, you can see this guy's using a whole barrel. Maybe they need to use just a half barrel the next time. What else am I seeing there? He's over on that left, on the right. He's cleaning with a hose. That looks kind of messy. If you look on the left picture, I see something I like, which is they're collecting the last dregs out of the fermenters into those little barrels. They're grabbing the heavy solids that way. The thing I don't like, though, is see that cloud of steam in the back? That actually, it's not steam, it's hot water, but someone is just running their hose to kind of keep things clean as they go. And your SOP will say that you don't kind of clean haphazardly, you kind of do it all at once, and that's the best way to conserve water. Measure and think are basically the two components of that. Okay, water recycling, a whole bunch of that is capture and reuse. But this is particularly galling. This is a cooling flow on some pumps upstream where you can't see it, and that clean water is going down the drain. There's two things that this person did. One is they just caught that water coming out, not into the drain, and loop it around. If it's really for cooling, that can only work part of the time. But you can do that. The other thing they did is they put a solenoid on it so that every time the pump stopped, the cooling flow stopped. Makes perfect sense. That's something that you can do. Your enterprising workers can practically do that plumbing themselves. I'm going to go on to a wastewater now, so I'm coming back to talk about solids once more. It's kind of a disease I have, I think. The solids that are on the left side here, those are all clean. That's a great way to capture solids because some animal is going to eat that stuff. It's a great way to recycle there. Contrast that with the solids in the lagoon. That's just a nuisance odor as soon as the temperature warms up. That's sort of a problem. Separating the solids is really a good thing because it keeps the waste strength of your wastewater down. Here's, thank you, the common methods that are used for wastewater discharge in Oregon are people who are located in the city, the municipal wastewater treatment plant. Land application of irrigation, well, the primary permit for wineries, I'll tell you about that in a minute, is for these irrigation systems, and there's a couple examples at the bottom. The one that doesn't get talked about quite so much is, I'm calling it subsurface discharge here. You probably think of it as septic tank leach field. Well, septic tank and leach field, that's about municipal wastewater with sanitary disease kind of problems. That's really not at all the way you would build a settling tank and drain field, is what I'm calling it here, because you need way more settling in an industrial a situation like a wine, much more than the homeowner model. For sure, you always need a screen right at where the wastewater exits the facility, because you have to get the big solids gone there. Regarding discharge to the city, solids removal, pH adjustment is commonly required, because that's low pH from a winery is kind of a jolt to the system. It's always good if you're going to the publicly owned treatment works. That's what that acronym stands for. Let them know at the city if you're going to dump a high-strength load of wastewater. If they just know that then they can cope with it a lot better. It's way better than when their incoming basins turn red. That's a terrible thing. Okay, the common things that you get charged on at a winery are the amount of flow, biochemical oxygen demand, that's basically the organics in your wastewater, total suspended solids. Here's an example of how a municipality would charge you on those things. Flow per 1,000 gallons. I picked $6. It's not a current number, but you'll get the idea from this thing. If you discharge 1,000 gallons, $6 a day. The BOD, biochemical oxygen demand, you're allowed to discharge 400 in that little formula for free, and then you calculate 550 a day. Suspended solids are easier to treat for a wastewater plant. That's 50 cents, $12 a day, $4,400 a year. That actually is sort of a reasonable number, but I just did one for crush here too, and you can see that during crush, you're up at 3,000 gallons a day. The wastewater strength in BOD has tripled, and TSS is 5 times as big. Well, when you do all of that, calculate the numbers, that's $50 a day instead of the $12, and during a 40-day crush season, that's $2,000. So during crush, your wastewater bill, that's about half of your bill right there. Okay, so let's go on to the general permit 1400A is what they call it for wineries. And the Department of Environmental Quality gives those out. It's a general permit. It's pretty simple to apply for and get. It's intended for processed wastewater and solids. They say it's supposed to go on winery property, but in practice it can be the winery or vineyards or other vegetated lands nearby. The flows for the permit are less than 25,000 gallons per day. That's about everybody. And you always have to have sanitary wastewater separated from the winery wastewater. You write a wastewater plan and you follow that. I just listed the 122 permits that are in Oregon presently. You can see by county where they all are. Okay, that's my story on wastewater, energy reduction, and things that winemakers and winery workers can do to conserve water. Thank you.
Yes, hello. Thank you for inviting me. My name's Ken Navidi. I'm with Bainbridge Associates. We are a rep firm for the state of Oregon, Washington. We handle flow meters and process control instrumentation for large industrial facilities as well as municipalities. A lot of what we do is trying to track a moving commodity, that being water. And it's difficult because it's always in motion. It's, we see water in evaporation, rivers, streams. We're pumping them out of wells, and we're using it through our process and dumping it back out to a lagoon for evaporation or to a public treatment facility. So one of the first things we do is we look at the regulations. If your winery is dumping on-site to a lagoon, you'll have typically an on-site discharge permit. That permit is given to you by the state. Inside those permits, we look for details of flow meters, and a lot of times what we see is it just calls out a flow meter. There's not a lot of direction as far as what's the accuracy of that flow meter, and does it need to be calibrated? How often does it need to be calibrated? So we tend to ask a lot of questions up front to the regulatory agency to try to figure out, okay, what type of meter is going to best fit this application. As far as offset in a collection system at a public wastewater treatment plant, you typically would be working with a municipal pre-treatment coordinator from the sewering district that'll come to you and say, okay, these are the styles, we need to have a meter as well. But a lot of times, to remain impartial, they don't want to kind of give away too much as far as flow meters. So it's not like working with the federal government on a lot of their national pollution discharge elimination and NPDES permit where it has to be officially stamped by an engineer. And an engineer, most of the time, this goes to the customer, and it's up to the customer to figure out what best meter to put in place. So keeping track of source water. Source water is clean water. Typically, it's a full pipe. We pump it out of a well, or we get it from a stream or river. There's a pressure system, so it's a closed access point. You could get it from a private well. You could get it from the municipality. The water line sometimes has to be sized for fire flow. And that sometimes makes it difficult for flow monitoring because you'll have a large size pipe diameter and it'll be a low velocity. Flow meters don't like very, very low velocity. They typically like to have some velocity so they can read that flow. So there's usually a set point that a flow meter will quit. Like on a 2-inch mag meter, you're looking at about 2 gallons a minute. So if you need to have anything less than that, or if it's sized up on an 8-inch size on a mag meter, you're looking at about 36 gallons a minute. So it could make it problematic. Also, you can measure flows on a pump runtime. So you set up a timer on your pumps, and it basically just records the pump on and pump off. Each pump comes with a calibration curve, and that tells you exactly what the pump efficiency is. So if my pump is rated for 50 gallons a minute, and I have it on and off, and I've recorded it 60 minutes of pump on at 50 gallons a minute, you just do the math. And so you can come up with a simple totalizer that'll give you a somewhat idea of what you're drawing out of the well. Wide track source water. You got to report to the state, the feds, the municipal government. For billing purposes, a lot of times when you go to those agencies, one of the first questions should be asked is, okay, what's my report cycle? Do I have to report, daily, monthly, yearly? What's my report format? Is it in a paper format? Do they want it wireless? Do they need it in the cloud where they can just go pull it off the internet? So there's a varying degrees of sending a report in. The billing unit is always a big question that we get with flow meters. It's what's the billing unit? Is it in cubic foot, acre foot? For instance, we have some clients in Yakima, and the municipality requires that they report in 100 cubic feet. That's one billing unit equals 100 cubic feet. So we basically have that meter run on a 100 cubic foot for sending out that data to the city. So what's the meter specifications and what are our accuracy needs? I got a slide here. Basically, these are the 4 primary meters that I'll go through today. There are a number of flow meters that are out on the market. There's no way I could possibly go through the variety of flow meters that we have to monitor wells. But these are kind of the basic 4, and these are flows that are going to a winery. The first type of meter is a turbine and propeller flow meter. These are sized anywhere from 2 to 72 inches. Basically, the turbine, water strikes that turbine rotor blade, and it rotates at the rate of the flow velocity. One thing that I should mention, all source meters have that fixed pipe, so it's a fixed area. Really, the only differentiation is how they're measuring velocity. So if you think about that, it's not a fluctuating level. That level is fixed. It's just how do you record velocity. So this one's recording it with a propeller, strikes the propeller, and then it runs up to a register. There's different gear drives, cable drive, propeller meters. There's all sorts of different style systems. They have analog, digital registers. You can now get these with battery operated that'll send out a signal so that you can read it via a remote monitoring system like The next meter here is a differential pressure flow meter. This is a V-cone style meter. I bring this one up because this meter is able to be used in really tight locations. By tight, I mean close to a pump, close to bends, close to Ys and Ts, or any valving that you have. If you have a partially closed valve, it doesn't matter. This meter works very well in that situation. It has a cone section right there, and the water's going this direction. There we go, that direction. And basically what we're doing is we're measuring the high pressure in front of the cone, and we're measuring the low pressure in the back of the cone. And so the meter consists of a precision flow tube, and then there's an isolation manifold, so the pressure comes through that manifold and up into what they call a differential pressure transmitter. So it's basically just monitoring pressure in front of the cone and after the cone. There's other flow meters, they call them orifice plates, that have basically it's a plate and it's squeezing all the flow through a circular portion. This meter was designed to limit some of the back pressure that it might have, so the flow could be turbulent in motion and it's circular, and as it comes up onto the cone, it straightens out. And so that's how they're able to monitor flows in applications where you got pumps and valves that really wreak havoc on flow. Those are very difficult applications to monitor full pipe accurately. This is an insertion mag style meter. It has a magnetic coils that's in there. This runs on what they call Faraday's law, which as water passes through a magnetic field, it produces a small amount of current, and that current is directly proportional to the velocity of the conductor, which is water. And so what we're doing with this probe is basically producing a magnetic field, and as water crosses around that probe, it's picking up the velocity. The limitations to this is that once you build this meter, it's custom made, so it has to go all the way through the pipe. So there's a valve right here, and how you install it is basically you got a saddle, and there's tapping companies that are out there all over the place. I think there's a tapping company, A&E, that's in Portland that does quite a few of these for us. You just saddle that meter and then put the valve on it, and then they put the cutting machine through the valve, and it cuts the pipe. So we can do this while the system's still under pressure. We don't have to take your source of water out for a day or so to put a meter in. A good thing about this flow meter as well is that it's very lightweight. It's easy to ship back to the factory if it needs to be calibrated. You can see over on the other picture that there's 2 people installing it. It really is an easy installation. Types of source flow meters. This next one here is a mag meter. It uses the same principle as the insertion mag. However, it has a full coil, magnetic coil that's in the body itself here. And so it's got a precision tube, the magnetic coil, and it's potted. These can be submersed in water. They can be buried underground. This is a predominant go-to meter from prop meters because there's no restriction inside the throat of that meter. And these are made by many, many, many different companies, so there's a highly competitive product. Process water is generally an open source. So now we're going to process water, which would be outside your plant. Generally an open source, partially pipe or channel. It's generally a non-pressurized gravity system. There are some minute exceptions to that, but generally flows by gravity, and it has variable flow rates and channel dimensions. The meters typically measure velocity as well as level. And the good thing about measuring flow in an open channel is that it's easy to access. It's easy to clean. It doesn't require taking the system out of work to clean it. And then then you're able to do an on-site calibration as well. Wide track process water, recycle, reuse, billing. Billing's a big one. As the price of water increases, most facilities are being billed on water comes in equals water going out. So you're being billed on that water that's coming into your facility. If you put a meter on your outfall, you'll find that you have evaporation. There's a lot of reuse. There's a lot of areas where you're using up and consuming water in that process. So a lot of times industrial facilities will go to the municipality and ask for a evaporation credit. Sometimes the municipality will allow it, sometimes they don't, depending on who the sewer purveyor is. If they don't, then basically we could go in, you could install a meter for 3 months and see what the numbers look like compared to your water inflow. If it doesn't work to your advantage, pull it out. The one thing that I will say about billing, though, is that Judith had discussed this. You want to make sure that the piping through your winery is tight. If you have high groundwater and you have pipes that are leaking, they could end up to your disadvantage to have a meter on the outfall. Also, flow-based sampling versus time-based. A pre-treatment coordinator will go out with a sampler, and most of the time they're looking for BOD and pH, and if and they're looking at those concentrations. So the pre-treatment coordinator may come out with a sampler, and you could do time-based sampling. Well, that just gives an equal weight per hour of samples. Now, you may have a little slug of pH that's sitting in the flow overnight. It's giving it equal weight as when you don't have pH and you've got flow. So what we try to do is go to a flow-based sampling system. So in other words, you have a flow meter and we're taking samples so that it's a more accurate representation of what you are sending to the public treatment facility. Types of open channel meters. You got submersible, aerial velocity flow meters. I've got flumes and weirs. I have a full-bore mag meter. That is the one that you use for incoming flow, and some have used it for outgoing flow as well. And then we have a non-contact AV meter. The first meter I'll discuss here is the ultrasonic. It's over a flume or weir, and this is the oldest form of measurement. This dates back to the Romans era. Basically, you have a ruler, or we call it a staff gauge, that sits on the side, and it's got 1-inch increments. Depending on the level of the flow through the throat of the flume or weir, we have basically a chart, head versus flow chart, that'll tell you how much flow rate you have depending on what your level of flow is. So the bad parts of these is that it generally takes a little bit more velocity than just, say, 7 or 10 gallons a minute. If you've got any sort of solids or debris, it generally tends to plug up. So you want to have a good amount of velocity through there. Also, it doesn't record very well in a surcharge condition, which is an overflow of water. Mag meters. For wastewater, with mag meters, if you have a tank and you're pumping it out, then you could use a mag meter. If you don't have a tank, some people have tried to use this trap method. what happens to debris and silt and any sort of sediment falls into that trap. So it makes it really hard. I haven't seen it successfully used in a gravity situation. This is a submersible AV sensor. I've got a green and blue one over there. These basically sit down in the flow. It measures liquid level with a what we call a bubbler or a pressure sensor. So it's basically monitoring atmospheric pressure and giving you the level of the flow. And then the velocity is read via electromagnetic, just similar to a single point magnetic flow meter. And we have a Doppler ultrasonic for velocity as well. Again, these may be maintenance issues. So they came up with the non-contact flow meters. There's about 3 different companies now that are starting to produce non-contact. Basically, it doesn't go in the flow, it sits up above the flow, and it's monitoring. This one monitors velocity via a radar. So it's just like a police radar gun, and you're holding it to the flow the whole time, and it monitors level via ultrasonic. The good thing with this flow meter is you're able to monitor flows down to a 1/2 inch at a 1/4 foot per second. We've had these down to 7-8 gallons a minute on an outfall, and then you can have it all the way up to a 12-foot diameter. So it's really got the largest flow ratio of any flow meter that's out in the market. They're reliable enough to be a billing meter. In fact, we set these up to send data to the cloud. They're so reliable, and also have them in solar. Tracking water through your plant, you could use a temporary flow meter. The one that we have here in the picture to the left is a saddle transit time ultrasonic meter, and the other one's an insertion mag meter. Now these are good for basically getting kind of a rough idea of what your flows are through the plant. Your limitation is accuracy. 5% generally is the rule of thumb for these. But they're very low in cost, and you're able to move them around. So if you want to get kind of a rough idea in tracking your flows, these are the type of meters to use. Points to consider when selecting flow meter: what's the quality of the water? Is it clean or dirty? Does the source water have iron or manganese? Iron and manganese will have an effect on my magnetic flow meters. It tends to stick to the magnetic source, and it makes cleaning an issue. Does my meter read my expected flow range? In other words, if I'm monitoring flow, if I get a flow meter that starts at 40 gallons a minute up to 400, and my plant is typically running at 10 gallons a minute, it's always going to show a 0. So you want to make sure that you're getting one that fits in your range. Can I shut down the service to install or calibrate? What's my preferred location to monitoring flow? And do I have an open channel or a closed pipe? What's my budget for purchasing and maintaining a meter? And generally, the higher the cost of the flow meter, the less it requires in maintenance. This is a slide here of a case study we have. This is Canoe Ridge Winery, Chateau Ste. Michelle. It's a flow dar that's sitting over the top of a pipe. We actually dug down to where the pipe's at. You cut just a rectangular portion so that it can see into the pipe. And then it's got a data logger that's inside here with a cellular modem, and it's all powered by the sun. So it's a completely remote setup. It basically keeps monitoring flow, and it sends that signal to our cloud hosting site. And here's another picture of this is Solari Winery, and same thing. This is a picture of a typical data summary that you can do. So over here in the category, you got a date and time stamp. It tells you what the time was that you had your highest flow rate. It shows you the date and time of the slowest flow rate. And then at the last column, it gives you your gallons. So it's giving you your average flow rate, and then it's giving you your gallons on this level. And then it gives you a total for the month. So you could just basically pull this off of the website or the software package, hand it to your agency. In summary, water sources in Oregon are finite, and conservation measures are essential. We'd like you to commit to reducing your winery and wastewater flows, and collect flow data and brainstorm reduction options. Use ideas from proven reduction strategies. A lot of that can be done by just calling other wineries that maybe have these types of systems. I always encourage that because sometimes when you get into meter specs, it can be confusing. The agency or the sewer purveyor may not be willing to kind of put themselves out there by making recommendations. So a lot of times, just look at your neighboring wineries for information on flow data as well. And just develop and implement a plan and celebrate your success. I thank you, and we'll open this up for questions. Thank you.
This question was for Judy early on. You had them tracking the water for each of their winery processes. How did they track the water?
I'll hand that over to Stuart.
Well, actually, that barrel thing that I showed you is one good way you do it. And then whenever there's clean water, there's small digital paddle flow meters that you can use.
They just had a small flow meter on a hose when the hose was running and it was recording. Sorry, I have to say this into the mic. They had a small flow meter that hooks onto their water hose, and then as they're using a hose, it's recording their water, and then they're hand writing it down somewhere?
Right.
Okay.
Yeah.
All right.
Hi, my question is about some of the realistic goals for water use. You had cited 2.9 gallons per wine produced and said that smaller wineries could use more. Can you define smaller and maybe give some range in there?
Yes. Most of the wineries in Washington are quite large compared to the wineries in Oregon. I believe one of the wineries, one of the WIP wineries was probably about 35,000 cases. The other 6 wineries were over 100,000 cases, and they also included Columbia Crest as well as Snoqualmie, which are huge wineries. I think Joy told me Snoqualmie crushed 15,000 tons this year, so they're big wineries. Smaller wineries, I'd say under 10,000 cases, and it would not be unusual for them to be using 6 gallons of water per gallon of finished wine produced, and that would be a sustainable measurement.
Hello, you mentioned using ozone for sanitizing to cut down on water use. Do you have a good source of information for sizing? And also, you say the ozone dissipates, but I've never heard any timeline for that, for when the ozone is no longer active.
So, do you have an answer for that?
I don't. We go to the ozone
Okay.
generator guys.
Yeah, we do. You usually go to the company that has manufactured your ozone equipment. We actually did some testing on that, and I believe that our 5 minutes was the average for it to be dissipated. But the best information you can get is to go to the company that you received your ozone machine from. And then the other thing that's really important is to calibrate your machine on an annual basis. Did that answer your question? Okay.
I have one right here. In terms of barrel sanitation, do you see a benefit to using these cleaners these machines that are UV or ultraviolet, or are those really energy intensive as well in terms of electricity cost?
I don't think it is particularly not. It's like the same as steam. It's like the same as steam, so it's. The steam thing, I actually need someone to tell me about this. It really makes nice sense to me that once you've steamed a barrel and you plug it up, when it cools, it sucks water out of the wood. That seems like a big advantage to me. Anyone has any input on that, I'd like to hear it.
Question right here.
In terms of the impact of site development, on water supply, I'm curious how much work's going on there, because in the process of vineyard development and site development for winery construction, oftentimes the runoff is increased by taking the holding capacity of vegetation out, and I've seen there's been a really broad mix of planning across different contractors and ownership and whatnot. I'm just curious what you might recommend for parameters in the site development stage for water supply.
What? Is this on?
This one is.
Okay. I can just answer a little bit of it. What's interesting is that two of the wineries that were in this WIP program that were looking at water conservation, they were brand new, very well designed wineries, and yet they could still make leaps and bounds in water conservation. I believe, I know in Washington anyway, and it kind of depends on the county. It's your county permitting that actually dictates what you have to do for site development. So, and I would assume it's the same thing in Oregon, it is that it's the county that dictates what to do. But there was one architect that we worked with actually on our site development portion of Winery Wise, who did incorporate doing everything that they could to utilize water on the site. And a lot of it had to do also with capturing rainwater. There were a lot of rainwater catchment systems, which this year would really work. Theirs was an underground cistern, and it was 4,000 gallons, plus they also had an irrigation pond that I believe was 90,000 gallons. The irrigation pond was used to irrigate the vineyard, whereas the underground one was used for water in the winery. This one, I believe, was one of the ones on Red Mountain. I would estimate that particular one was between 7,500 cases and maybe down to 5,000 cases. That was in Washington. No, they did not.
So the question was about grant funding?
Yeah, no, they didn't have any grant funding for that. And I don't know if your local utilities here would offer some type of rebate or some type of financial assistance to do that. I don't know. Sorry.
We got one more here.
My question has to do with you made a reference to evaporative lagoons that many of us use in Oregon. And I'm wondering if one of the things I've seen that permit and read it, I'm wondering if there's for DEQ, if there's a standard, what does that evaporative lagoon need to look like based on how big the winery is? Where does it placed? What is it lined with? Are there criteria in Oregon for that?
There are loosely criteria, I would say, and there's plenty of room for negotiation, but in practice, if you have a double-lined lagoon for evaporation, the only one I've ever done actually in Oregon was double-lined, and it had leak detection between the two liners. That's the general kind of construction that you would use. It's worth noting that an evaporation pond has salty water in it by evaporation. So it's regarded as a high-strength wastewater. It's problematic in that sense.
How do you deal with salts in the effluent systems?
Did someone say constantly?
How do you deal with it?
There's really only expensive ways that you can deal with salt in process water. Generally, when we do irrigation scheduling, if you will, where you have some process water and some supplemental irrigation water to keep the crops alive, you actually need, you can't put 2 feet of winery process water to meet irrigation demands. It's more like 7 to 10 inches of irrigation per year. That is to say, you have to lightly load and spread it out.
One more over here.
This is actually for whoever over here asked about water per case. With Live, we do track it, and if you reach out to Chris Sarah, it might be on the website, I'm not sure. But we, as Live certified wineries, we track our case per water per case, and you could find out that number for a smaller winery versus these larger wineries. I don't want to pull the number off the top of my head because I can't remember, but like I said, Chris Sarah's around here, and just ask him, he could probably pull the number out and at least give you a starting point. What we run into with tracking ours is the fact that the vineyard water is mixed in with the winery water, so we don't pull out what's getting sprayed, and so it makes our particular water case production go up per case.
Any other questions? We have.
Okay.
If not, I just want to thank our speakers.
Thank you.
For a great session.